Hello everybody again. Today we shall try to solve the problem number 2 from the 28th Junior Balkan Mathematical Olympiad. You can read the problem. I shall explain, although we have a triangle and one X circle of the triangle and also two other circles as circumcircles of particular triangles, and we need to prove that 3 points are collinear. That is the problem. I shall explain in detail what we need to do. Actually, I prepared a picture with also with some initial guesses how to solve the problem. So let me first explain what we have. We have a triangle with vertices A, B, and C. I denoted angles of the triangle as alpha, beta, and gamma. I didn't denote the sides, but sides will be, the opposite sides will be A, B, C. And first, what we have this X circle, which this X circle here, it touches the continuation of side AB here in point D, touches the continuation of side AC here in point E, and touches the third side of the triangle BC here in point F. The center of that circle here is called J, and we can obtain the center as the common point of bisectors of some angles. Here is a bisector of this exterior angle here. Here is the bisector of this external angle here, and they meet here in point J. Also, we pick an arbitrary point on BC here, this point P, and then we have two triangles. This is one triangle. Actually, sorry, here the triangle BDP, and another one is triangle here CEP. And then I constructed another two circles, which are circumcircles of those triangles. So they go through the vertices of those triangles. Simply now I needed bisectors of sides to intersect in the, for example, this bisector on one side and this bisector on one side for this triangle CEP intersect in this point, which I called S2, and which is the center of that circle. And also here we have one bisector here and another here, which meets in this point, which I called S1, which is the center of the second circle. And those two circles obviously intersect in point P, but there is another point which is called Q here. So they intersect in two into points P and Q, and also this JF here is actually right. Here is actually right triangle, as already denoted here, because point F is the point where the first circle, X circle of the triangle meets the side BC, and the continuation of JF here intersect here on this continuation there is a point R such that AR is perpendicular. So here we have a right angle here. And we need to prove that those 3 points are P and Q are actually collinear, that they lie on each on the same line. So what is the idea of the proof? Actually, I shall be honest, I'm not sure that I shall be able to find the proof. It's pretty complicated. You need some very clever idea to prove this. And I started with something with trigonometric functions. Actually, I'm without them, I'm even more clueless. So what is my idea? My idea is to prove that this angle delta here is equal to this angle epsilon here. By proving that those two that tangent of delta is equal to tangent of epsilon. So I didn't finish the proof. I simply started this. But let me first explain why it is enough to prove that delta is equal to epsilon. Namely, one axis of epsilon goes through centers of the circles. Let me call them K1 and K2. So through these centers S1 and S. Actually, here another one. Another axis of that triangle is so one axis goes through centers S1 and S2. And we know that S1, S2 is actually perpendicular to PQ. This is a common fact. We have two circles and the line through two common points is actually perpendicular on line which goes through the centers of the circles. So this is a known fact. So we know that S1, S2 is perpendicular to PQ. And now we are going to prove that S1, S2 is also perpendicular to RP. So if we prove this, we are going to our proof will be finished, because that way will be it will be proven that P R and Q that P, R, and Q are on the same line, because we are going to prove that S1, S2, which is perpendicular to this one line PQ, is also perpendicular to this one R, and they have common point P, so those 3 points will be collinear. But why is this true? Why S1, S2 will be perpendicular to R? P? Because another axis of this epsilon angle is actually perpendicular, see right angles here, to the one axis of this angle delta. And we are now going to prove that those two angles, delta and epsilon, are equal. And as they are acute angles, we will actually prove that other two axes of those angles are perpendicular. We will actually prove that another axis of epsilon, which is this S1, S2, is perpendicular to another axis of delta, which is actually RP. So we need to prove that delta is equal to epsilon. Well, that is an idea, but actually I am not sure how to prove it efficiently. I draw the picture, I found an idea, but I'm not sure how to prove this efficiently. What are difficulties here? Point P is actually an arbitrary point on BC. I denoted this distance PB as D. So we have arbitrary points, so delta can be an arbitrary angle depending on the position of P actually. And I started I started with this trying to calculate those angles actually. So I am using trigonometric functions. Tangent of delta will be this side PF over this side RF. And so how I obtained those two? PF is actually this side of the triangle A minus this D and minus this CF here. So from the whole side A, I'm subtracting D, which is here below, and I'm subtracting CF, which is actually here. And here I'm using that I actually know what is CF. That CF is S minus B. I am now going to explain this. Namely, AD and AE are equal because that is simply a distance from A to common point of the tangent with the circle here and another one here. So we know that these two lengths are equal. So this one AD is equal to this one AE. This is a very known fact. So actually we know that this is equal to half of the parameter of the triangle ABC, because this in similar fashion, this CE is equal to this CF, and this BD is equal to BF. So this BD plus CE is equal to the whole side A here. And so altogether, AD plus AE is the perimeter of the triangle, and each one is equal to the half of the perimeter, which is denoted as C. So this is C, and as this is B, this will be S minus B, and also this will be S minus B. Similarly, this is S minus C, and this will be S minus, actually, this will be S minus C. This is D, this is arbitrary point P. So when we put C minus B instead of CF here, we obtain this guy here. And RF, the another side in this ratio, is actually equal to this one, which is B prime. I denoted this point as B prime. And that can be simply obtained from this right triangle here as the cosine of this angle here, which is obviously beta minus right angle, is equal to BB prime over C, and we obtain that actually BB prime is C times this cosine, and this cosine is actually sine of beta, and we finally, using also that A plus B is actually parameter 2S minus C, I obtained this final expression for tangent tangent delta. And for tangent epsilon, I have this ratio S to G as this one S to G over this one S1 G. So I denoted this point by G. This S1G is actually equal to FH. I denoted this point here H, and this FH is obviously actually half of the side of the triangle A2, because okay, let me see. Yes, because this is the middle of the CP, and this H is the middle of PB, and altogether FH is actually A over 2, half of the A. And I'm going to calculate this guy as to G, which is here in numerator of this fraction, as the whole S to F here, S to F here, minus this Fg, which is also equal to this S1H. And now I shall need another paper to trying to calculate this S to F and this and this S1H, and trying to prove that this guy here is equal to this guy here. I'm not sure that I'm going to able to calculate all this, but let's try to do this. Namely, what is S to F? This guy S2F here, which we need here, is actually the distance from the center of the circumcircle of the triangle CEP from his one side, CP. So let me try to draw this. Let me try to draw this here to explain what we have. So we have one triangle and its circle around the triangle. And we have a center of the circle, S, and we need to calculate this distance from S to the side. Let the side be called A, nothing common with this A here in our problem, but it will be understandable, and the opposite angle is alpha, and this distance is simply x. What we know is that this angle, which I'm now going to draw, is double alpha. This is the common theorem on center angle, and I'm not I'm not sure how to say at the moment, but it's a common fact that this alpha is equal for each point. I take another point, this is also alpha, and this is 2 alpha. So this one guy, half of that, this will be 2 alpha, and this guy here will be alpha. And actually we have that tangent of alpha is equal to a half over x. So actually x will be a half multiplied with cotangent alpha. So we are using this, we are going to use this formula to calculate S2F and to calculate S1H, because in a similar fashion, S1H is the distance from the center of this circle K1, which is circumcircle of the triangle BDP from one side, which is BP. So, okay, I shall try to write down. Okay, maybe I shall need this picture again later. But now I'm going to use. Okay. Okay. Let me calculate here, because I shall ruin something, I guess. So let me, for example, take now black one. So what will be S2F? S2F, according to this formula, will be half of this side CP, which is actually A minus D. Here below is D. A minus D over 2 times cotangent of which angle of this opposite opposite angle of CP in this triangle CEP, so this one here. So I shall write down this as cotangent of angle CEP. And in a similar way, S1H, which we have here, which we have here, will be, so the distance from the center S1 of the circle K1 from the side PB of triangle BDP. So the side is D, half of the side is D over 2, multiplied with cotangent of the opposite angle, which is this one, so angle BDP. So it remains somehow to calculate those two cotangents of the angle CEP and the angle BDP. Okay. Okay. When I was drawing the circle, I had an idea how to calculate that, but I didn't remember, so I shall need to think again about that. Okay, so the idea is that I draw perpendicular lines from P to sides of the triangle, this one here, obtaining this point, let me say, okay, I don't have this notation so far, so let this be P1, and the perpendicular of P to another side, actually its continuation, it's here P2, and then I will have that cotangent of CEP is equal to P1E over P1P. So P1E over P1E is the cotangent of this first angle, which we need here. And how to calculate those? So I calculate P1E as this guy here plus this one which is S minus B, and this one here will be actually this guy here will be actually this one here, CP, which is actually A minus B times cosine of gamma. I'm calculating from this triangle here. So cosine of gamma is this CP1 over CP. So CP is A minus D, so this is it. So this P1E is, as I said, A minus D times cosine gamma, which is this one, plus this one, which is plus S minus B. And how I obtain P1P, which is this one, P1P, which is this one, is also calculated from this triangle, but now as A minus D times sine of gamma. Sine of gamma is this P1P over CP, which is A minus D. So this is the formula for this cotangent. And the second cotangent, which I need here, cotangent of the angle BDP, cotangent from this one. Sorry. Okay, I'm missing some layers here, so that is the problem with this program. So this cotangent will be this P2D over P2P. And this one in numerator, P2D, is actually BD, which we already know is equal to S minus C. So this whole line PD is, as we said before, equal to S minus C. And we shall subtract this little guy here, this BP2, which we are going to obtain from this triangle here. And from this triangle here, this is going to be, so let me see what is this going to be. So cosine of this angle, which is 180 degree minus beta, and okay, maybe in my picture beta is uh, beta is more than a right angle, more than 90 degrees. Okay, so I'm proving actually in one case, but never mind. We are going to finish this like this. This cosine will actually be minus cosine beta. So this cosine will be this guy BP2, which we need over D. So this guy will be actually D times cosine of this angle, which is 180 degrees minus beta, but I shall write instead beta and plus here. The formula should be the same with acute angle beta, but just point P2 will be on another side here. The formula will be the same. So this is P2D, and what is P2P? P2P is this, and sine of this angle, which is actually the same as the sine of beta, is equal to the side we need, PP2 over D. So this will be simply D. So this will be simply D times sine of beta. Okay, I shall now need to write down the formulas which I obtained here on the paper. So I obtained that S2F is equal A minus D over 2 times this first cotangent with it, which is A minus D times cosine gamma plus S minus B over A minus D times sine of gamma. And I obtained for S1H that this is D over 2 times this second cotangent, which is S minus C plus D times cosine beta over D times sine beta. Okay, and I shall now open a new page and write down the formula which I obtained, and we shall try finally to prove that tangent delta is equal to tangent epsilon, thus completing the proof. Okay, we have a new layer here, and I shall write down the formula which I obtained previously for tangent delta. I obtained the formula that this is S minus C minus D over S times sine of beta. And for tangent epsilon, I was calculating that this is S to F minus S1H over half of the A. And then I was calculating that S2F is actually A minus D over 2 times the first cotangent we were calculating, for which we obtained A minus D times cosine gamma plus S minus B over A minus D times sine of gamma, and minus, now we are writing down expression for S1H. We calculated this as D2 times the second cotangent, for which we obtained S minus C plus D times cosine beta over D times sine of beta. Okay, long expression, we shall try to simplify. First, what we notice is that we can cancel this A minus D with this A minus D here, that we can cancel this D here with D here, that we can cancel this 2 and this 2 together with this 2 here. And so after those cancellations, we have that tangent of epsilon is equal to A minus D cosine gamma plus S minus B over sine of gamma minus S minus C plus D times cosine beta over sine of beta over A. So we shall put on one denominator this, so it will be sine beta sine gamma in the denominator, and also we can put this A here, and we have A minus D times cosine gamma sine beta plus S minus B sine beta minus S minus C sine gamma plus actually minus D times cosine beta sine gamma. And what I was saying at the beginning, I'm completely not sure that I'm going to be able to prove that tangent delta is equal to tangent epsilon. Maybe I will, but it's really not simple to prove this way. Really, it isn't. You probably need a more clever idea without using trigonometric functions, but I was not able to see this today, so I'm trying to prove the way I can hope that I can obtain something. So let me try to simplify now this. So what I have here. Uh, okay, I first have this A times this, which is A cosine gamma sine beta. Then I also have okay, I shall write this one here as simply as it is, sine minus s minus b times sine beta. This one also here as minus s minus c sine gamma. And now finally I have minus d times, I have, let me show this, I have minus d here, which is multiplied with this guy here, and minus d here, which is multiplied with this guy here, and those two together are actually equal to a sine of beta plus gamma. This is known addition formula for trigonometric functions, and that is actually equal to sine of, we are in a triangle, so beta plus gamma is equal to 100 degrees minus alpha, and this is actually sine of alpha. So we have here simply d times sine of alpha over a multiplied with sine beta sine gamma. So now let me try to distinguish what we have. This guy here over this guy here, we can cancel a and sine beta. We can cancel a and sine beta, and we obtain cosine gamma over sine gamma, which is cotangent of gamma. Okay, this is the first term. In this second term here, we can cancel sine beta and obtain s minus b over a times sine gamma, plus in this third guy here, okay, we have actually minus s minus c, and we can cancel sine gamma, and here we have a times sine beta. Okay. And finally we have minus d times sine alpha over a times sine beta sine gamma. Okay, and finally I'm going to use the famous sine theorem for write down this in red here. We have sides A, B, C, and the opposite angles alpha, beta, gamma, and we know that A over sine alpha is equal to B over sine beta is equal to C over sine gamma. In the first formula for tangent delta, we have C here in the denominator, and so instead of A here, and A here, we shall try to get C using that this one is equal to this one. If we multiply this with this and this with this, we obtain that A times sine gamma is actually equal to C sine alpha. So let me use this. This first one is cotangent gamma, which is okay, plus S minus B over. So instead of A sine gamma, I am going to write C times sine alpha minus S minus C. Okay, now I have A times sine beta, but we shall again try to use C here. So we can try to use so C times sine gamma, excuse me. I cannot put C times sine alpha times sine beta from here, but also divide it with a sine gamma. Okay, sure what I'm going to get here. Minus, and in this last term I have d times sine alpha in numerator, and in denominator I have A times sine gamma, which I'm again using this one. This is C times sine alpha times this guy here, which is sine beta. And actually I can now cancel this and this. And this last guy here is actually recognized here in the first formula, minus d over c sine beta. We have here this, and we have here this, so we are on the right track to obtain something. So we need to prove that this first part here, this one, is equal to this one here. Okay. I shall again write down the formulas which I need to verify. I need to verify that, and then I shall open a new layer that we can write this down. I need to verify that C minus C over C times sine beta, this is the first part of the tangent delta, is equal to cotangent gamma plus S minus B over C times sine alpha minus C S minus C over C times sine alpha times sine beta over sine gamma. Okay, I wrote this down. I shall now open a new layer and make it visible. And we shall now write down what we still need to prove. So to finish our proof, we shall need to prove that for sides and angles of the triangles, the following identity is true, that S minus C over C times sine beta is equal to cotangent gamma. I shall write it as cosine gamma over sine gamma plus S minus B over C times sine alpha minus S minus C over C times sine alpha times sine beta divided by sine gamma. I shall write this sine divided by sine gamma as here. Okay, can we prove this? Can we prove this? Okay, what is S minus C? S minus C is actually A plus B plus C over 2 minus C, which is altogether A plus B minus C over 2. In a similar fashion, S minus B is A plus C minus B over 2. So I shall write this down now. So here I will have A plus B minus C over 2C sine beta on the left-hand side equal to cosine gamma over sine gamma here, plus this S minus B will be A plus C minus B over 2C sine alpha minus, and actually S minus C is again A plus B minus C over 2, but here multiply with sine gamma, and here multiply with sine alpha sine beta. Okay, let me see. How to try to prove this in the easiest way. Okay. Let us try to multiply with 2c sine beta, that we have only a plus b minus c on the left hand side. What we get on the right hand side is 2c cosine gamma sine beta over sine gamma plus a plus c minus b multiplied with sine beta over sine alpha. Okay. Minus, I was wrong in the first one. S minus C, A plus B minus C over 2. I'm missing C here. So here I will have 2C sine, I will have only sine alpha here. 2CS I'm multiplying with this and this, I'm getting sine alpha, and I will have A plus B minus C times sine gamma. Okay, is this now clearer or not? Maybe still not. So I have A plus B minus C equal to C cosine gamma. Maybe I also have an error in calculation, that is also possible. Plus now I can put those two together as sine alpha, and actually I have A, which is multiplied with sine beta minus sine gamma, minus B, which is multiplied with sine beta plus sine gamma, and plus C, which is multiplied with sine beta plus sine gamma. I'm bothered with this cosine which I have here. I already used the sine theorem, but cosine is not so easy to obtain with the help of theorem of cosine is saying that cosine gamma is equal to a squared plus b squared minus c squared over 2ab. So I would prefer sine and not cosine here. And so what can I do here? I'm not sure about this cosine. Maybe I can do the following. Well, well, okay, let me see. Cosine gamma is equal to cosine of 100 degrees minus alpha minus beta, and that is minus cosine of alpha plus beta. And using addition theorem, that is sine alpha sine beta minus cosine alpha cosine beta. Okay. Uh, I'm close, but it's not easy to see everything. So this guy here is actually equal to B. A over sine alpha is B over sine beta. This is B. Also, A times sine gamma over sine alpha is C. So this whole thing here is B minus C. Is B minus C. Okay. So I can cancel all this with this. What else can I have here? Also this guy here, C sine beta over sine gamma is B. So we are left to prove that A is equal to 2 cosine gamma, which is 2 times, well, but I'm again obtaining cosines. I was going to use this, but again I have cosine alpha, cosine beta. Maybe I need to multiply cosine alpha, but alpha plus beta will be no, I have nothing here. So I have this 2b cosine gamma. So let me see what we have. Plus, we left here with sine alpha, and in numerator we have minus b sine beta minus b sine gamma plus c sine beta plus c sine gamma, and c sine beta is equal to b sine gamma. C over sine gamma is b over. So this and this can be cancelled. Okay, can we try to write this way? So A is equal to 2b times cosine gamma, which is a squared plus b squared minus c squared over 2ab. So we can cancel 2b and 2b here. Minus b times sine beta over sine alpha is actually b times b over a, again from the sine theorem. And we have also plus c times this sine gamma over sine alpha, which is c over a. And when we multiply with a, this is equivalent to a squared equal to this guy here, which is a squared plus b squared minus c squared, minus this guy here, when we cancel a and a is minus b squared, and this guy here, when we cancel a and a is plus c squared, and we cancel this and this and this and this, we obtain finally that a squared is equal to a squared, which is quod erat demonstrandum. Sorry for this long proof, and sorry for using trigonometric functions, but I was simply not able to prove this another way, and even this was very difficult to me. So I'm not so good in geometry, and see more in such a complex picture which we had at the beginning is out of my scope. So this was the only way I was able to prove this. My congratulations to all those elementary school students who solved this, and many of them solved. I'm impressed. I'm really impressed. I'm happy that I managed to prove anyway this and maybe I will probably not obtain full 10 points here, because I was not sure how I used actually that AB is less than AC. I'm still missing something here in this problem, I guess. I didn't actually. Maybe I was using this when drawing the picture, but not in any other way. Okay, see you soon. We shall solve soon problem number 3.